Building a gem host in MIStudio. Build complete tool or host applications without programming in Ergotek's MIStudio drag and drop IDE. This tutorial follows on from the TransSECS gem host tutorial to show how to monitor values and events and to store reports in a database. It demonstrates reading the database and displaying the data in a tabular and graphical form. Recipe selection and tool control are demonstrated by using the lot ID provided by a loaded event to select a recipe and send a start command, that includes the recipe, to the tool. For this demonstration we will again use the standalone tool that is provided with TransSECS. In MIStudio we have started a new project and added some annunciators and a button to the design window. We copy the first of these to the diagram window. More information on this is in the MIStudio introduction video. The messages and components generated by TransSECS are now available in MIStudio in addition to all the usual components. The green equipment config component provides a representation of the tool. We add this to the screen. This component can be configured in the Properties panel or we can enable runtime configuration. To do this, we choose Expose Properties and enable additional properties that can be changed at runtime. From the Data Flows tab we choose a broadcast server. Using the Manage Connections feature of MIStudio we associate the broadcast server with the PPID value. The value of the PPID variable will update whenever it is received from the tool. It is in our started and loaded reports. Those reports are linked to our started and loaded events and so either of those events will update the PPID. Connect the broadcast server to the annunciator to display the value of the PPID. Select the started event in the simulator. Click the Sim button to go online with the tool. You will see messages in the message panels as MIStudio connects to the tool. Enter a PPID, a recipe name. Press the Send Selected Event button to send the started event. We see the PPID in our annunciator. Add another broadcast server. We'll attach this to the started report so that we can store it to our database. We use the Manage Connections again to make this association. We choose the rptid.started.database tag which allows us to store the data directly. Copy the annunciator to the diagram window and connect it to the broadcast server. We'll use the final annunciator to display the time that the report was received. To do this, we use the Date Info manipulator from the Time and Rate tab. Storing reports to a database. We'll use our report output to store the contents of the report to a database. SECS gem data can be challenging. Different tools produce different data. The information you want from a metrology tool is not the same as from a stepper. Even different events can have different data. In contrast, reports are the same within a tool and so can be stored, analyzed and compared, regardless of which event generated them. This makes them a convenient unit of storage. It's easy to create reports in TransSECS and link them to any events. Now we see how easy it is in MIStudio to store and manipulate that data. From the Database tab we add a Database Connection Manager. We're going to use a connection to a SQL Server database. We configure the connection manager for that database. From the Database tab choose the triggered historical. Set the connection. Set Create Table to True. A table matching the report will be created automatically. Set a table name, here we use the table name started event. Connect the broadcast server to the map trigger of the triggered historical. We'll generate some started events. From the More Layout tab we add a bootstrap table. From the Charts tab we add a line chart. And copy them to the diagram window. From the Database tab we add a database raw table lookup. We connect from the status output of the triggered historical so that the lookup will be triggered whenever data is stored. We enter a SQL statement that retrieves all the data for the started event. And connect the result to our table. When we generate events, the data is stored in the database. The request for data is also triggered and that data is displayed in the table. We added the process temperature VID to the started report in TransSECS so we can display it to a chart. To chart the data, we take a database array raw lookup and configure it to read the process temperature from the database. We connect the status output of the triggered historical to the input of the lookup and the output of the lookup to the line chart. The lookup will again be triggered whenever a new value is saved to the database and the chart updates. Sending messages. Sending messages is easy using the TransSECS generated beans in MIStudio. We'll send a request for data by triggering a message send on a button. Then we'll send a start command to the tool. The start command needs a recipe name, PPID. We'll use the lot ID sent in a loaded event to trigger a database lookup that returns the recipe for that lot, populates the start command and sends the message. Copy the button to the diagram window. From the gem host primaries choose the S6F15 request event report message. Connect from the button to the send message input of the message. To push the button we need to view the test frame in MIStudio. We see messages sent and received, and data updating. Now we take the start command message and drop it on the screen. We take a database raw lookup edit to the screen and configure it. We then add another broadcast server and connect it to the variables.vid.lotID tag. Connect the broadcast server output to the trigger of the lookup and the result output of the lookup to the recipe name input of the message. Whenever the lot ID is received, the corresponding recipe name will be selected from the database and set as a parameter in the message. We trigger the send of the message when a loaded event is received, which just requires another broadcast server connected to the variables.rptid.loaded.database by managed connections, and then connected to the send message input of the message. Now, when a loaded event is sent, the correct recipe for the lot will be read from the database and the start command with that recipe will be sent to the tool. Select the response to the start message. Here we select to always respond with a good response. For the test lot ID, the recipe name is test recipe. Send the loaded event by pressing the Send Selected Event button. We see the test recipe in the PPID field. For the lot ID, the recipe name is lot ID recipe. We've seen how to gather data from events and use an event received to trigger an action. We've displayed values and stored report data to a database. With these concepts and the many components in MIStudio, we can easily build fully featured SECS host applications. These can include events, alarms, SBC, fault detection and AI. The application can be deployed to an IoT device, a server, or even to the cloud.